So to start off our video today, I'm going to begin with a quick review of what we learned in our last video. What we did is we did a comparison of these different cylinders that had various porting configurations to find out which porting gave us the best performance. And to do that, we used a 200 millimeter barrel, which you can see compared to the other barrels is a mid-sized barrel, but still fairly short. And the results that we got as we went from cylinder to cylinder, you could see that the performance slowly increased. We went from a little better than 300 feet per second up to around 350 feet per second with our largest porting. And this was a bit of a revelation to me because I went into this initial test with the feeling that the more air you could jam into the barrel, the faster you're going to get the BB to go. But it turns out that was not necessarily so, because as we progressed and the velocity got higher, there was actually less displacement. There was less air getting forced into the barrel. So why was that? Why was the BB moving faster? Well, my theory is that having that port in there, when the piston begins to move forward, it's not immediately getting compression. It can actually move a lot faster till the point where it finally gets compression, so it can get a faster piston movement, which interprets into a higher velocity with your BB. So having the larger porting gives you better performance. Which begs the question, what happens when you do different barrels with this same test? So I went through a whole slew of tests, and I used essentially the same parameters that I used with the initial test. We used our ICS split gearbox design in our test bed, which gives us fairly easy access to the cylinder, so we could swap them out pretty easily. We used the same cylinders, which ranged from unported up to a fairly large porting design. The major difference is that we used barrels that ranged from 200 up to 400 millimeters in pretty much in 50 millimeter increments to see what the differences were in velocity. And that gave us results that looked like this. So you could see with the 200 millimeter barrel, which was our initial test, saw the most dramatic increase in performance. When we went from 300 to 400 millimeters, you can see these four lines up top, it was pretty much a flat line. There was not a huge amount of difference going from cylinder to cylinder. But when we went up to the cylinder that had only 15.5 cubic centimeters of displacement, suddenly the performance just fell off a cliff. Why was that? Number one, you can see that the port size is about the same. The only major difference is that the port is a little further forward. So this has about 19 cubic centimeters of displacement. This has only 15.5. So that difference of having less air, it was just not enough air to effectively accelerate the BB down the barrel, and that's when we saw the performance drop off. One major takeaway that you can have from this is that as far as porting goes on cylinders, this is going to be, the one right in the middle is going to be the most common that you see out there. Like almost all of the factory built guns are going to come with a ported cylinder that looks exactly like this, where it has a 15 millimeter port with about 19.5 cubic centimeters of displacement. So, and even if you change from one to the next, you could see that the performance really doesn't matter all that much. So it's, you know, as far as what kind of increases in velocity you're going to get, especially with longer barrels, as long as you're not using one of these oddballs that has only like 15.5 cubic centimeters, you're going to get fairly reliable, consistent results from it. And to get this particular cylinder, this is really an oddball in that the hundreds and hundreds of cylinders we've got here, we only had like 2 of these. So this is a very rare design. But looking at these results, it made me wonder that you could see that the larger barrels lost velocity, but the shorter barrel, the 200 millimeter barrel, continued to gain velocity all the way up through all of the cylinders, which made me ask, well, what would happen if we used a cylinder that had even less displacement? This one has 13.1 cubic centimeters. So you can see compared to this has 15.5. This has only about 13 cubic centimeters, so this is even less displacement. What happens if we try that? You could see that the results were pretty profound, and all of the barrels, including the 200 millimeter barrel, lost performance and had lower velocity than the previous cylinder. Which got me thinking, you know, out of being thorough, what if we tried the whole test using another set of barrels? So I purchased a whole nother set of matched barrels that came from a different manufacturer, and these ranged from 200 to 400 millimeters, and we ran the same tests using these, which gave us this result. So when you compare them head to head, you can see that the results are very similar, which was reassuring to me that this was not some sort of fluke, that no matter which manufactured barrels that we used, we got very similar results. Obviously, they're not exactly the same. There are some manufacturing differences in the barrels, and there's probably some differences in the bores of the barrels and so on. So there are some nuances to it, but essentially the fact that the curves looked pretty much the same was pretty encouraging to me, that we were on the right track as far as what kind of results we get. So looking at these graphs, it got me thinking, well, we're losing performance with this particular cylinder, but this is a mass-produced cylinder, so this must have some sort of utility. So I figured, well, we're going down to a 200 millimeter barrel. What happens if we go to even shorter barrels? So I got a 150 and a 100 millimeter barrel, and I decided to run all the same tests using even shorter barrels, which gave us these results. So when we look at the results of this test, we're looking at the 200, the 150, and the 100 millimeter barrel are the bottom three lines in this graph. You can see that they saw increases of performance even up to the cylinder that had 15.5 cubic centimeters of displacement, and only lost performance with the final cylinder that had only 13 cubic centimeters of displacement. The shortest barrel, which is a 100 millimeters, still had a pretty consistent result going from the final two cylinders. The longer barrels, you could see, lost velocity. So there definitely is a line, depending on how long your barrel is going to be, that you actually can gain some performance. When we're looking at just the shorter barrels, you can see that it's definitely a more profound difference, where we're getting a difference of about 100 feet per second more velocity out of it. So there definitely is some benefit to be had. On the other hand, when we're using the longer barrels, you can see that pretty much you're not really going to be getting that much of a benefit. So if you're using longer barrels, you could probably just stick with the standard 15 millimeter port with 19.5 cubic centimeters of displacement, which for the most part, if you're just getting a cylinder with your gun, this is what you're going to get anyway. And if you use anything else, it's, you know, as far as the standard cylinders, you're pretty much going to get the same kind of results. And then you can see with the final two cylinders that had the least amount of displacement, you're definitely going to lose dramatically performance from that. So there's probably more to benefit, I would say, when you're using the shorter barrels, if you're looking into this. One final note on this test, I did find some cylinders that are mass-produced. These are made by Prometheus, that they actually give you a recommendation for the barrel length based on the porting configuration on the cylinder. And there is other information out there that is available if you want to, do a little more research and see what works best for you. Of course, we're going to post these results on our website, so if you could use the data for your own purposes, feel free, just log on, and we'll have the results from a lot of the different tests that we've done here. And we will, in the future, do tests on these. I'm somewhat curious about them because the porting configurations on these have the ports all the way around the circumference of the cylinder, and I want to see if that makes any kind of difference, so stay tuned for that test in the future. But just to wrap things up, I think the results all speak for themselves. If you want to find out more about this and, you don't want to have to deal with it yourself, just bring your gun in here. We do these kind of upgrades here in-house. So just feel free to bring your gun in and we'll work with you to get the most performance you can out of the gun. So until the next time, don't let the bastards get you down.